What's up, YouTube? Today we're going to be looking at the strategy design pattern. Now you would need to understand polymorphism, so if you don't know or don't understand it quite well enough, then I suggest looking at my video on polymorphism before you attempt this one. And before you wonder what's the difference between the strategy pattern and the template method pattern or any other pattern for that matter, stay tuned because we will be discussing that at the end of this video. So the definition from the Gof Book is define a family of algorithms and encapsulate each one and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. This may not make a whole lot of sense, and I don't think it's the best way of explaining what the strategy is or what the strategy pattern is really and how best to implement it. So we'll discuss this as we move through this, and you'll see code examples. So I'm hoping that'll help you solidify the actual what the strategy pattern is and how and when to use it and why it's useful. Now there's a little bit of UML here. This UML is sort of straight from the Gof Book, but I've of course made my own classes and things, but there are certain relationships or indications from the UML diagram that I'd like to explain here. So the client code is the code that wants to use the strategy. So it's frequently called the client code. It's not the client as in client server, it's just the code that is using the thing. That's the client. And what we have is the client code that has a dependency on the number sorter context. In other words, it uses the number sorter. The context is a term from the strategy pattern, but typically you don't name things context, but for the sake of this discussion, I'm going to use the word context so that you understand that that's the context part of the strategy pattern. Now the context in turn is, in this case, that the hollow diamond is indicating an aggregation. And there's two forms of associations. There's an aggregation and there's a composition, and we'll be looking at both of them. So if you're not familiar with the difference between aggregation and composition, then an aggregation is the looser form of a relationship. So if a class aggregates other classes, then those classes are contained within this one class, but this one class does not own it, as in it doesn't own, typically in object parlance, they don't own the lifetime. In other words, these other classes that this one class is aggregating can exist without the one class. So let's say over here, for example, if I'm looking at the number context, the number context depends on some sorting strategy base class implementations. In this case, we have sorting strategy heap as one implementation, sorting strategy insertion as another implementation, and sorting strategy quicksort as the third implementation. The number sorter context class is aggregating these concrete classes here, the ones at the bottom here, by way of the diamond, the hollow diamond here. It means aggregation. So essentially this class, number sorter, is aggregating these other concrete classes, but it does not own the lifetime, and they're not kind of contained within it. So an example would be, you have a university or a home that has a room. So in a university, there's a department, let's say, the computer science department. The computer science department can't hang off by itself. It is composited by the university. So that relationship means that without the university, the notion of a department has no meaning. So a department is composited, is a composition, or the relationship between a university and a department is a composition. And effectively, the department cannot exist without, or has no meaning to exist without the university itself. However, the professors of a department can exist by themselves as other professors in other colleges, and maybe just human beings by themselves. So that relationship between the professor and the department is an aggregation. So both are contained, however one owns and one does not in object-oriented terms. In English language perspective, the idea is that one can exist without the other. So in this case, because the professors can exist without the department, the relationship they have with the department is that of an aggregation. Whereas you can't say I've got a bedroom and there's no home. That doesn't make sense. So the bedroom is composited by the home, because without the home, the bedroom has no meaning, right? Without the department, without the university, the department has no meaning. So that's again a relationship of composition. So the hollow diamond shape indicates aggregation in UML. So what it's saying is the number context class is aggregating these three concrete classes. All right. And if you look at the methods, you'll see that then the client code knows of the number sorter, and it says, hey, number sorter, get me a sorter. And the client code is then providing some sort of an identification to the number sorter, so the number sorter can decide, well, based on this identification, I will give you one of my three, in this case, the three strategies, right? And so it returns a sorter. And then if you look underneath over here, I say that the client gets a reference to the specific sorter because it asks for it by some sort of identifier. And then once it has the sorter, it calls the sort method on it, providing it with listed the numbers that it has, its own numbers, saying, well, here are my numbers, go sort them. Now, on the face of this, it seems very innocent. And before we go into a deeper discussion, I'd like to present an alternative. Now, this is the design that's presented in the Gof Book, or this is the design that they talk most about in the Gof Book on the strategy chapter. They do call out certain drawbacks and certain alternatives just by way of passing, if you will, simply 1-2 sentences. We are actually going to discuss an alternative, which is sort of briefly mentioned in the book, and then another alternative that's more common, at least in my case, in real world usage. I found that to be a little more common than the alternative, but we'll discuss both of them. So you'll understand the difference between this and the other two. The other two are actually very similar. There's a slight difference in the third one, if you will. So what they say here is that it's not them saying it, I'm saying this. The client maintains a reference to the number sorter, the context, the strategy context. The client is aware of various sorting strategies, so the client can ask for, so it knows there's, let's say, a heap sort or a quick sort or a insertion sort, and so it's asking the context, the number sorter, for a specific strategy by name. So it's aware of the different strategies. And somehow it also understands when to use which one. Now, that may not be always the case. Maybe it doesn't know, one, that there are so many strategies, and then which one, based on what do I decide which one to use. And it turns out that the list class in .NET, the sort method on the list class, actually internally uses a strategy. You wouldn't know it, would you? You've used the sort method, but you probably didn't know that it does that. And that's the point. That is a slightly different variation of what is being discussed here in the first not the first strategy, the first implementation option for the strategy pattern. And the client is aware of the various sorting strategies and when to use them, and the client specifies to the context, the number sorter, which sorter it wants. Now keep this in mind, because this is the sort of the point of contention I have, or the discussion that we're going to have after I present the other option. The code that I'll be presenting in this video will be for the second option, not for this option. But remember these things. The client maintains a reference, which is fine. The client can maintain a reference to the context. The client is aware of the various sorting strategies, and I'm not sure I would agree with that. How would it know? And how does it decide? Now, some of the drawbacks which I mentioned, not necessarily exactly in this fashion, but they do mention some of the drawbacks of the strategy, and these are some of those. The client must be aware of the strategies, of course. If the client is going to have to ask for strategy by name or some sort of identifier, then the client must be aware of those strategies. It must know how many there are and what their identifiers are to be able to ask for them. And the client must understand how these differ so that it can make the right choice. So how does it know what's the difference between a quick sort and an insertion sort and a heap sort, for example? I mean, do you? I don't. why I do, but as an example, if you're going to somebody for help, you probably don't know enough about whatever that person is doing for you, which is why you need their help. Then how would you know what the strategies are to be, which strategies to be used, right? That's my beef with this. Clients must be exposed to implementation specific needs or issues, and that's sort of the aspect. The client needs to know, hey, you know what, in this case the quick sort will be better. Well, actually no, in this case the heap sort actually is a better option, so I should ask for the heap sort, right? And that's the part, that's the rub. So these are the drawbacks, and as a result of which I actually don't like the strategy pattern as presented in the book. However, they do present an alternative. They don't present, they talk about an alternative, and that's what we're going to be talking about. So the alternative is that, and there's a subtle change here, a few subtle changes here. The alternative is that in the number context here, the method is called sort. The method is not say get sorter, it says sort. Unlike in the previous one, it said get sorter. What's really happening here in this case is that the client code is asking the number sorter to do the sorting. The number sorter then has its own strategy for deciding which algorithm to use. Should it use the heap sort or the quick sort or the insertion sort or whatever the sort that might be there. The number sorter context or the strategy is actually aware of the reasons for why I should use one or the other of the algorithms, the sorters, if you will. And so it says, okay, you give me the numbers and I'll sort them for you. So once it has the numbers in hand, it can use that information, the numbers itself, and typically it's the number of elements that helps it decide. And we'll see some code for this. Based on the number of elements in there, it decides to use either one or the other algorithms for sorting. So it is, if in fact, the strategy class, the number sorter, in this case, the context. And it also owns the decision-making logic for which strategy to use. Now, just to go back to the previous, the previous implementation options. Strategy. To me, this is very much like just the plain old plain Jane factory, because that's what I would use a factory for. The factory is a factory for a family of classes. The factory in itself is not part of this family, but it is a factory for a family of classes. And you walk up to the factory and say, hey factory, given this information, please give me the thing that represents that one of those family, right? And that's a family. So this is, to me, is a family. I would not use, or I would not consider this to be the strategy. This is just a simple factory. Because the difference is this. Let me talk about the second option, second implementation option, and then we'll go to a little bit of discussion. So I said here, this relationship, and the diamond here is now a solid diamond, is not a hollow diamond. And in UML, a solid diamond indicates a composition relationship. In other words, the number sorter class composites the sorting strategies, the different concrete implementations of the sorting strategy. It is not an aggregation, which means the number sorter owns these classes. And you could also say owns, meaning it doesn't let anyone know that it contains them. It's almost like saying from the outside of the house, you can't see what rooms there are. That from the outside, you have no business knowing where the rooms are and what they are, how big they are, right? That's the whole point. So the strategy in my mind is hiding from the client code its strategies. So therefore, it owns those classes in terms of lifetime, but also owns them in terms of it doesn't hand them out. A factory's job is to hand out the things it creates. Right? The factory produces things. So you can go up to a factory and say, give me this class, typically in a hierarchy. So its job is to give you an instance of the thing you asked for. I don't believe a strategy's job is to give you the thing that you asked for. Then there's no difference between a strategy and a factory. Now, granted, the factory pattern came out many, many years later, and maybe it's a sort of a bastardized version of the strategy that's talked about in the Gof book, or the one that talked about the most in the Gof book. And they have their place. I just wouldn't call that a strategy, at least for the sake of having conversations with people. I would not call that the strategy. I would call that more like the factory, unless I'm mistaken. Maybe you guys know better. I don't know. To me, that strategy looks like a factory. This strategy, however, because it aggregates the concrete implementations, these guys, it does not expose what it owns to the outside. So the outside has no notion of the fact that there are these 3 different algorithms. And the decision-making logic as to which one to use effectively is also part of the strategy of the context, which means it's completely self-contained. Right? I hope you understand the difference between these 2 different implementation possibilities. The second one, let's say you go up to a garage with your car and you tell the person, hey, I want to repair this car. Do you know which mechanic behind the scenes is working on your car? Do you want to decide that? Or do you rather the garage owner decide that? He or she probably knows better which mechanic is better suited for the make and the model of your car. That strategy that is employed by the garage or the owners or the management is not known to you, and you probably don't want to know. You shouldn't have to be the one making the decision. Heck, what are you going to pick the mechanic on? How good he or she looks, how big or strong they are? You couldn't possibly make the decision. So rather than leave the decision to the customer, the garage owners or the management decide for you. Just bring the car, tell us what's wrong with it, and we'll have it fixed. Right? That's the whole point. That is a whole lot more useful than saying, which mechanic do you want? And you're standing in line there and you're thinking, oh my gosh, like how do I decide? What's the criteria I would use? I don't know how to fix the car. I don't know what's wrong with it. You follow? So for me, a strategy is a lot more useful when what I don't want to know and couldn't possibly know, as in it's a specialty that I don't know. I'd rather that class that claims to be the specialist decide on which strategy to use internally. I don't want to know that. Right? So I take my car to the garage, it gets fixed, and the car comes back. I didn't know what happened. Right? I didn't ask for the mechanic by going to the store. So the first option, I keep wanting to say strategy. The first implementation option is like saying you go up to the garage and say, okay, I need a mechanic. And they say, like, mechanic for what exactly? Well, I've got a Mercedes and my car is not starting. It could not be starting for 10,000 reasons. Maybe there's a specialist mechanic that knows how to work on a Mercedes but not on the problem that you're having. Right? There could be some other mechanic that's the specialist in that area, and he or she would be able to better fix that car for you. And the factory is more like saying you go up to a store and say, I need a spark plug for my car, make, model, year, so-and-so. And you take the spark plug and you go off. Now, apparently you know what to do with the spark plug, so therefore it's good for you. So you use the factory for when you need something, you know how to use it, and they all have the same methods of implementation, same signature, same interface. So they all, the parts of the factory have the same interface, and so once you have a spark plug from a certain company, you can just fit it in. Right? You don't have to know whether it's from NGK or somewhere else, and there's the tools required to fit that spark plug back in the engine block. They're not different. No matter what the make, a model of the year of the spark plug is, it'll just fit in if you have the right tools. But this is the same tool required for all the manufacturers. And so that's kind of like the strategy in the first option that was presented, which is I'll tell you what I want. So I'll tell you I want an NGK spark plug, and then I will fit it because I know how to do that. Right? That's like because the client is calling the sort method, and the client is asking for specifically the heap sort. I hope this is all making a lot of sense here. The difference might be subtle, but I see it's a very, very big difference. So if you haven't understood the difference, please rewind. Hopefully I've been doing a good job of explaining this, but I think I have. So go back, watch it again, maybe it'll come to you. Moving on from here then, I would prefer this design because I'm saying I know there's a sorter I would rather give my numbers to the sorter to sort. Let the sorter decide based on those numbers what strategy to use. I don't know whether I should be using a heap sort, and I don't want to know. I don't want to know. Listen, if you weren't useful to me, would I use you? You'd be the middleman. If I have to just come to you to get a sorter each time, and I have to tell you what sorter to give me, and then I do the sorting, do I need you? No, exactly. That's the point. That's the point. Okay, let's look at some code now. I think that's the last of the slides. Yeah. So now the code is fairly simple. I have this is the client code. The client code meaning the code that's using the strategy or the context. So I've got a number sorter. And now this is actually implementing the second option, implementation option, what I would actually call the strategy, the real strategy. I don't consider the other one a strategy at all. I consider that a factory. So there you go. Okay, so it's got a number sorter context. I'm giving it those names specifically because it's, we are learning something, so I want to use the same vocabulary over and over so there's no confusion throughout the video. And once I have the sorter, I'm giving the sorter the numbers I want it to sort. I'm not asking it for the actual strategy. I don't know what algorithm to use. I have a bunch of numbers. I need them sorted. That's what I know, right? So I give it the bunch of numbers, and the numbers come back sorted. Fantastic. That's exactly what I need. I don't want to get in the business of understanding which algorithm to use, first of all, how many there are, and when I should use this one, when should I use that one, and do I even want to know that there are 3 or 4 or 5? That's too much information. It's not a clean decoupling between the client code and the strategy, right? So now if you go into the sort method in the number strategy, you'll see it has a way to determine which sorting algorithm it's going to use based on the numbers. So let's go in there. And I've given a description here in the comments. You can read that. I'll make this code available on my GitHub. You can read that. And essentially it says, okay, well, given the numbers, I will decide, and it'll return an enum, which is also private or internal to this class. So the enum is not exposed on the outside. It's internal to the class. And it's got the 3 options: the insertion sort, the heap sort, and the quick sort. Right? So that's it. Anyway, once it knows what sorting algorithm to use, it then, using the switch case, just news up either the insertion sort or the heap sort or the quick sort. Now these are implemented classes in their own fashion, meaning the insertion sort implements an insertion sort, and the quick sort implements a quick sort, and the heap sort implements a heap sort. That's fine. But this context, the number sorter context, decided based on knowledge it has and understands. The client code gave it the numbers to sort. The strategy used the numbers to decide which strategy or algorithm to use, called upon that class. So it actually, once it got an instance back for the sorter, it calls the sort method and then returns the result of that to the client code, and the client's happy. Right? That's to me, this is the cleaner implementation, the more decoupled, cleaner implementation. Let's look at another example here on Windows Form application. Simple application. The code is actually simple, but this is very real world in the sense that this pattern is a very useful pattern in the real world. But I'm trying to keep the implementation simple so you understand the purpose, and you can translate that to your own requirements. So the form has got, let's say, media files. I'll explain the thing here. So depending on whether you have a video file or a music file, audio file, or do you have an image, the idea is that you want a strategy that internally knows how to produce thumbnails. The client code doesn't want to know how to produce thumbnails. It's not in the business of producing thumbnails. It's business to do bigger things, and it says, I've got the file, can you please just give me a thumbnail back? The strategy internally has in this case, two implementations, an audio thumbnailer and a video thumbnailer. And they're very different. If you've ever done this work, you'll know that the actual implementations are very different. So depending on the file type, meaning the media type or the MIME type of the file, whether it's a video file or an image file or an audio file, it will use the right algorithm to extract the thumbnail from that media file. Right? So that's what the idea is. So I'm going to show you the form here. Let me make it is the startup project. So if I look at the form, it's a simple form here, and the code is also fairly simple. When the button is clicked, it says media thumbnail context. Now normally in my production code I call it strategy, I don't call it context. So media thumbnail context dot generate thumbnail, given the media info. In this case is giving the media info, which includes the actual, let's say, media file, the video, photo, or audio file, and that file has a bunch of metadata in there, so you can use that. So the client code has to give the context, the strategy, information, or sometimes the actual thing, like it gave the numbers, and the numbers was enough to determine which algorithm to use. In the case of the video file, also the actual media file is enough for the strategy to determine what media file to use, and it does that, right? So it's not it doesn't need any more information, but that's not to say that you may not need any more extra information in order to help the context determine what strategy to use internally. Right? If you look at the get thumbnail method here, then it says, well, based on the MIME type, which all media files have internally as metadata, I'll either use, if it's an audio file, I'll use the audio thumbnailer. If it's a video file, and there could be n number of video files, I'll use the video thumbnailer. If there's anything else I don't know what to do, that throws an exception, right? And these thumbnailers know how to do that. The audio file thumbnailer knows, okay, giving me an audio file, I can extract the thumbnail. Actually is actually embedded in the file itself, but it's for audio files. And for video files, it's typically a certain frame in the video, and you have to know how to extract that from a video file. So that's a completely different implementation, and you can do that, right? So if you see this running, so we have a drop down that has audio or video. So let's say we pick audio first. We say produce a video, create thumbnail, and it produces a thumbnail is so big, and a certain aspect ratio, and it says I'm a video thumbnail. And when you pick the audio, it creates a thumbnail, and the audio is different. The code in the client has no idea how to produce this. It just says, hey, media thumbnail or context, just produce a thumbnail. Here's the media file, produce a thumbnail, and it's done, right? Very simple implementations. Hopefully, that'll make it easier for you to understand. Now, in both these cases, if I look at my the thing here, the slide here, I want to just call out as per the Gof Book. They maintain that these are in a relationship, meaning they're all descending from some base class or some, what they call interface, which is actually just a base class. So they have the same interface, they belong to the same family, if you will, and then their implementations are different. And the number context then uses those internally. It does not expose them right to the outside. Now, in the real world, if you design a strategy like this, so this is the second implementation option, that does not expose the strategies to the outside. The client is not aware of what the strategies are and how to decide which one to use, right? Does it really matter that these different strategies are from the same family? I mean, how does it matter? The context doesn't care. There's no need for these implementations to be in some form of relationship. For example, let's say you want to compress a file. You could gzip compress it. You could lzip compress it. There's a dime a dozen compression algorithms. But these things, at least the ones you get like are in the open source, they don't have a common ancestry. So what? If internal to the context, you decide whether you want to use gzip or lzip or whatever the other zips are, how does it matter the consuming code? It doesn't matter, right? So that's another advantage to implementing the strategy in this fashion, is that the implementation and therefore the fact that these classes inherit from a common ancestor or not is irrelevant. The logic, the reasoning for when to use which one is still internal to the context or the strategy, and it can write whatever code it needs to write to produce the end expected result. And so by not exposing the sorters, for example, to the outside, you're not forced to have them descend from a certain base class, or they don't have to be in the same family, right? So that's another advantage, if you will, of containing, compositing the various implementations you might have. Now, certainly, if you want to add more algorithms, it might be easier if they were in a family, but it really doesn't matter. As far as the client code is concerned, there's no impact to it. It doesn't have to know of some other ancestry. You got a new strategy, let's say you only had gzip and now you have lzip, the client doesn't care, right? As long as the zipping happens, is better, is the smallest size possible, how does the client care? So that's that. Now let's look at sometimes when you're learning patterns new, as in you're new to these patterns and you're listening or hearing or learning this one pattern for the first time, there may be some confusion in your mind. Now, certainly when I learned about these patterns, I remember, okay, so what's the difference between the template method pattern and the strategy then? Like, there are subtle differences, and you would be wondering, so what's the difference, right? And unless you use these patterns many, many times in the real world, you really won't get a sense of, a really good sense to be able to distinguish one from the other. So, I'd like to explain the difference. So in the one case, the strategy is either composition or aggregation. So it's delegating the work to another class. So one class is delegating the work to another class, right? Because it's either compositing or aggregating that class or classes. The template method pattern is really a form of inheritance only. In other words, the base class determines a sequence of steps, and the base class is the one that calls the template method that in turn calls the sequence of steps in a specific sequence. There's no other classes, right? I mean, there are descendants, but that's not considered other classes in the sense that when you new up the class, you're newing up the descendant, not the ancestor. So it's not like one class is using other classes, right? Whereas in the case of an aggregation or composition, one class is either aggregating or compositing other classes, and so there are other classes. Whereas template is really in a hierarchy, it's inheritance, right? With the strategy, you can vary the entire algorithm, meaning how you zip a file or how do you create a thumbnail. There's no relationship between creating a thumbnail for an audio file and creating a thumbnail for a video file. Absolutely no relationship. Whereas with a template method pattern, the sequence of steps in order to achieve the thing you're trying to achieve is predetermined by the base class. What descendants can do is decide how to change the implementation for their requirement, for their need. They cannot change the order or the sequence. So there's no, in the template method pattern, there's a dependency, if you will, of the order and the sequence. Whereas with the strategy pattern, the variations can be vastly different, and so you're not beholden to a certain template method, a sequence of steps. And the strategy is considered to be more like a coarse-grained thing, which is it's almost, it's not a bad thing in this case, but it could be like, you're taking a hammer to, put a little thumbtack into your, the cork board. So it's coarse-grained. That's not to say it's a bad thing, because whereas the template method is sort of more fine-grained. By fine-grained, it's a subtle thing, right? In inheritance and polymorphism, just a subtle thing. Whereas with a strategy, the implementation is going to be vastly different. So you don't have to worry about, it's not a subtle change, it's a coarse-grained change. So that's the way I would explain the difference between a strategy and the template method pattern. I'm hoping all of this has made a lot of sense to you. And if it has, please give me a like, give me a thumbs up. If you haven't subscribed already, please subscribe, and please hit the notify button also. If you have any questions, you have any suggestions, you can hit me up on the comments below, and I will see you next time.